Not right now.
Okay. Well, I'm gonna have to talk to him at some point because he's like 2 months late. I'm putting this grade in that's worth 50 points. That says I have nothing. So now I have a C in his class.
Another thing about is everything.
You specifically should be sorry.
I know. Like, why doesn't he do?
It's your fault, Mr. Albaugh forgot to put in my grade from 2
Why
months
doesn't
ago.
you agree with me? Like, why doesn't
Usually
you
it is,
practice?
Alright, today we are going to start the final chapter for this class. Chapter 11 is all about sequences and series. There's only 3 sections in this chapter. The first section is just kind of an overview of sequences and series. So, a sequence is just a list of numbers. Okay? Now, they give us some more complicated definitions here, but essentially a sequence is just a list of numbers. And we can write rules for these sequences to get any number in this list. Right? So a finite sequence is just a list of numbers that ends. Right? There's a finite number of terms in the sequence, and an infinite sequence is one that doesn't end. Okay? There are an infinite number of terms. So the first idea here is if we are given a formula, right, that formula is called the general rule, or it can also be called the general term. To get each item or each term in the sequence, all we're going to do is plug in whole numbers. Okay? So to get the first term in a sequence, I'm going to plug in 1 for n. So I'm going to say a sub 1 equals 2 times 1 plus 1. So that'll be 2 plus 1 is 3. Then these questions ask us to get the first 4 terms. So then my second term, which I would denote as a sub 2, is going to be 2 times 2 plus 1. A sub 3, which would be the third term, would be 2 times 3 plus 1. And the fourth term, 2 times 4 plus 1. Right, so the first 4 terms in the sequence would just be 3, 5, 7, 9. Right, and then technically this would keep going, but we just want to list out the first 4 terms. Okay. Questions so far? It's pretty straightforward for this first part. And all we're doing is plugging in values. So let's take a minute or two here and see if you guys can get some values for the next couple here.
You should have done it. would normally post a picture of you with hard eyes and the drooling emoji on my normal story, but today it's a little bit different. The only people on my private are people that I profess with, I don't go to kids. Makes you feel any better. But at the same time, it's only a compliment because I'm not. It's beautiful competitive stuff. When is the test on this?
It's such a waste. It's such a waste. It's just like we've learned it's just like 12 years now. Why don't you take this class?
Oh!
So I can get free college.
Alright, did we get these values for B, C, and D? Okay.
Okay, on C, is that a negative part of, like, the negative 2?
So if it were -2 to the n power, we would have to have parentheses around the -2. So in terms of order of operations, since there aren't parentheses, we would have to do the power first and then take the negative sign into account. So for this one, all the terms will end up being negative. For D, the signs alternate because we have -1 to the n power. So -1 to an odd power will be -1. -1 to an even power will be +1. So that's why the signs alternate for D, but not for C. Okay. Any other questions on these ones? Okay, so now let's take a look at, given a list, writing a rule. So for these ones, there could be a lot of different things happening. Okay? In the next two sections, we'll look at specific ways to write rules for arithmetic and geometric sequences. But here, in this first section, we just have a list of numbers, and we just need to try to figure out the pattern.
Oh, yeah.
Okay? So in this first example, we're going to write a sub n equals something. Right? That's how all of these rules are written. So what's happening here? We want to think about, well, if I plug 1 in here, how can I get 1? If I plug 2 in here, how can I get 4? If I plug 3 in here, how can I get 9? So what's happening for this first one? Yeah, we're just squaring that value. So the rule here would just be a sub n equals n squared. How about the second one here? Again, we want to think, well, if I plug in 1, how can I get 2/3? If I plug in 2, how can I get 3/4? If I plug in 3, how can I get 4/5? What's happening here?
Be 1 minus 1 over n.
1 minus 1 over n. So let's test it. So if I plug in 1, I would get 1 minus 1 would be 0.
That already doesn't work.
Yeah. So not 1 minus 1 over n.
Is it something?
It is something. Does anybody?
Is it n plus 1 over n plus 2?
That would work here. N plus 1 over n plus 2. Okay. So we can treat the numerator and denominator separately here. Write a rule for each numerator and denominator. So if I just look at the numerators, well, they're going up by 1 every time, starting at 2. So this would be 1 plus 1, 2 plus 1, 3 plus 1, 4 plus 1. I can do the same thing with the denominators. Right? This would be 1 plus 2, 2 plus 2, 3 plus 2, 4 plus 2. Okay, so I can write the rule as n plus 1 over n plus 2. How about in C here? C, we start looking at alternating signs. We did an example up top where we had alternating signs. So if I want to go -3, +6, -9, +12, how could I do that?
Negative 3n.
Like that? around. So if we plug in 1, negative 3 times 1 is negative 3. If we plug in 2, negative 3 times 2 is negative 6. So we're close, but not quite. How, in the up top, how did we know that we were going to have alternating signs? There was a negative in parentheses, and specifically a negative 1, right? So if I know that I'm multiplying the value by 3 every time, but I want the signs to alternate. If I want the signs to alternate, I'm just going to throw a negative 1 to the n power onto this. Right? So I know that I'm going 3, 6, 9, 12, but I want the signs to alternate. So negative 1 to the first power is negative 1. So that would be negative 1 times 3 times 1. If I want this to be positive, then negative 1 to the second power is positive 1 times 3 times 2 would be positive 6. Negative 1 to the third would be negative 1 times 3 would be negative 9. Okay, so whenever we want alternating signs, we're going to need a negative 1 to a power. Okay? So in D, again, we have alternating signs here. I want my first value to be 0, then 1/2, then negative 2/3, 3/4, negative 4/5. So what could we do here for this one? Well, let's try it. N -1 over n. So yeah, if we plug in 1, that would be 1 minus 1 would be 0 over 1, so that works. If we plug in 2, that would be 2 minus 1 would be 1 over 2, so that works. If we plug in 3, 3 minus 1 is 2 over 3, but we want it to be negative.
Would it be that multiplied by the negative 1 to the n power?
Let's try it. So, if we plug in 1, that'll still be 0. If we plug in 2, that'll be negative 1 to the second would be positive 1 times 1 over 2. If we plug in 3, negative 1 to the third power would be negative 1 times 2 over 3. That works.
All right.
Right? So to deal with alternating signs, we're going to have negative 1 to the n power. Questions on those? Alright, so the next idea then is a recursively defined function. So this is just where we are defining the next term based on the previous term. So in this first example, we're given that the first term is 25, and then it says the next term is just the previous term minus 6. Right? So that's what this means. So a sub 1 is 25, then a sub 2, okay, my next term, is going to be my first term, my previous term, minus 6. So a sub 2 is going to be 19. A sub 3 then is going to be the previous term, 19, minus 6. A sub 4 will be the previous term, minus 6. A sub 5 will be the previous term, minus 6. Okay, so a recursively defined sequence just says, well, I'm going to use the previous term somehow to get the next term. Questions on that? Alright, real quick, try B here. Find me the first 5 terms of this recursively defined sequence. We get -3, -1, 3, 11, 27. Maybe. Alright, so all we're doing in a recursively defined sequence is using the previous term to get the next term. Any questions? Alright, then the next idea on here is a factorial. So, a factorial is just defined as taking a number and multiplying all of that integer along with all of the previous whole numbers together. So, the notation is some number and an exclamation point. So, for example, if I want 5 factorial, we define that as 5 times 4 times 3 times 2 times 1. Alright, so that would be, what, 20, 60, 120? So 5 factorial would be 120. A special case, 0 factorial, we say, is equal to 1. So, if I want to take that idea and simplify expressions like all of these examples down here, we can use the definition of a factorial. So, 3 factorial, we know, would be 3 times 2 times 1. And 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1. So what we can do in something like this, we can cancel out the 3's, cancel out the 2's, cancel out the 1's. And we would just be left with 1 over 6 times 5 times 4, which would be 30 times 4 is 120.
We'd have to do it that way or just simplify it afterwards.
If we get into like really big numbers, your calculator can't do them. Like if I give you something like 100 factorial over 98 factorial, your calculator just can't do those larger numbers. So that you have to understand what a factorial is. Simplify. So we actually don't have to write out every single number like this. If we look at B, we get some larger factorials. I don't have to write out 16 numbers here. All we need to do is say, well, 16 factorial would be the same as 16 times 15 times 14 factorial. Right? I don't have to write out the rest of them. I'm just going to go to whatever this one is. So then this is over 14 factorial. Those cancel out then. And I'm just left with 16 times 15.
It's pretty neat.
Pretty crazy. So what is 16 times 15? 60, 240?
Damn. Yeah.
Well, my thought process was 15 times 4 is 60. Then times 4 again is 240. So do stuff like that in your head. Just break it down into something you know.
You're a math wizard.
Try C real quick here then.
That's
Ta-da, I did it. That was tough.
What's tough?
Almost didn't survive that. Oh. Hey. Oh.
We get 1 over 13. Yeah. Alright. So what about examples then where we have n's in our factorial?
You just put a 1.
What do you mean put a 1?
I don't know. I really don't know. I'm just trying to go.
So for D here, I still want to use my definition of a factorial, right? So if I want to think about n minus 3 factorial and writing that out, well, I'm going to take my first number would be n minus 3. The second would be n minus 4. We want to subtract 1 from that number.
Oh
So-
yeah, never mind.
Yeah.
Never mind.
So if I wanted to keep writing this out, right, I would just keep subtracting 1 from that number every time, right? We could do the same thing with the n minus 2. I would just keep subtracting 1 number every time. So what we want to think about, and we want to try to compare it to what we did in B and C here. I want to start writing one of these out until I get to the other one. Okay, in this case, n minus 2 is greater than n minus 3. So if I write out n minus 2, I'm going to end up with n minus 2. Then my next value would be n minus 3. So instead of writing this as n minus 3 times n minus 4 times n minus 5 times n minus 6, I would just write that as n minus 3 factorial.
Why do the values keep going down?
Because that's our definition of a factorial, right? We start with that number, and then we just keep multiplying it by the next integer down. We keep subtracting 1.
I thought it only worked with positive numbers.
It does. That's true.
I guess.
Yeah, so in these examples, I mean, n would have to be something larger than 3.
Yeah. Okay.
Okay.
Okay, so here, I mean, I can cancel out these n minus 3 factorials, and this would end up just being 1 over n minus 2. Okay, so whenever we have something like this, we want to start with the larger one. Start writing out each term until we get to the other one, essentially. Okay, so see if you can try E and F real quick here. Yeah, so you'll start off by subtracting 1 That's you start with the value that you have.
So do you multiply those though? Like do you distribute the n?
Oh, you could.
Because
Yeah.
I did.
Yeah, I mean, you could write that as n
So you
squared
can write
minus
it
n.
as n squared minus n. Okay.
Sure. Yeah.
That was kind of fun. A little bit. I mean, not a lot of fun, but it was a little fun.
A little fon's better than no font.
That's what I would say. Can you stop making noise? All right, yeah,
Thanks.
yeah, you're good.
Did we get n times n minus 1 for the first one? And 5n plus 1 times 5n for the second one? Questions on factorials? All right, then the
Just wait for another 16 minutes and then forget whatever it was you were going to say.
What?
The last idea in this section then is to talk about the sum of a sequence. Right? The sum of a sequence is also called a series. Okay, so I'm just taking a list of numbers and adding them all together. For this, we are going to use what's called summation notation. Right, it's just a big old sigma. So whenever we see something like this, the bottom value, right, is called the lower limit. Value on top is called the upper limit. And what we do is just take each integer in between the lower limit and the upper limit and plug them into this rule right here to get a list of terms, and then I add them all up. For example, on A here, my rule is just the value itself. So this is saying take all the numbers starting at 1 and ending at 9, plug them into this rule, and add them up. So that rule is just the number itself in this case. So I'm just going to take all the numbers from 1 to 9, add them up. So, what is that? 6,
45.
15, yeah, 45.
Good job, Alec.
For B, this is saying take all the numbers between 0 and 4 and plug and cube them, and then add them together. So 0 cubed is 0. 1, I guess I can write cubes out first. So 0 cubed plus 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed. So that's going to be 0 plus 1 plus 8 plus 27 plus 64. What did you say it was?
Ooh.
Okay. So see if you can try the next two here.
No way. Shoot, what's 32 minus 1?
473 and a half, I think.
Okay, I'll write that down. We still add them all together, all the answers.
Yes.
Wow.
Add them all up.
That kind of makes me excited. 36. 60 plus 12, 72. That turns into 70. Mr. Flashback, I'll blow my nose.
I don't know, I got 248.
Oh, yes. Hey. Shut up. Precisely my voice.
We're supposed to do that too. Oh my gosh.
Okay, that's right. Did it.
How did you get one?
So 2 to the 0 power is 1.
It is. Oh yeah, anything to the zero.
Anything to the 0 is 1. And then we defined up top that 0 factorial is also 1.
I forgot.
What? Are you looking? Trying to get punched in the face, loser?
He is stressful.
I'm not the actual.
Literally just knocked you out.
I'm not the actual Jesus Christ, so that's true.
I also did you double check that.
We got 7, both of us.
For a D?
Yeah.
Yes.
What?
You gotta trust us.
It's 5 times
Wait.
30 over 6.
I used the calculator.
Would be 38 over 6 plus that reduces the 4 over 6. 44 over 6.
Oh yeah, it would be. That would be 4 over 6. Yeah.
You had a good one. That's right. I had this. I have to call it. You have to give it this.
It only took him 12 years of education, but he can finally have this stuff.
Whenever you get a paycheck, you have to legally give it to Brady. Legal.
All $2.
Yeah.
Mr. Pratt is here.
At least 2 hours. Yeah.
So I taught that.
Alright, did we get 248 and 7?
I copied the answer down, so yes.
You did at least 2 hours. Mr. Pratt is here.
Watch one day he said break that ticket for you.
I'm counting.
I laughed so hard.
Any questions on evaluating a series? All right, then the final thing is writing a sum in summation notation.
What?
So, if we are given a list of numbers down here,
This is fancy.
we need to first determine a rule and then somehow put that into summation notation. So I need to figure out the smallest value I'm going to plug in, the largest value, and a rule. So if my numbers are 2, 4, 6, 8, 10, 12, 14, first of all, what rule could I write? Okay, again, thinking if I plug in 1, I get this. If I plug in 2, I get this. If I plug in 3, I get this. What could my rule be? N plus 2? Let's test it. If I plug in 1, I get 3.
What if I'm starting at 0?
What if you just did n times 2?
Okay, so yeah, let's try that. If we start at 0,
Oh, never mind.
then I'll get 2. If I plug in 1, I'll get 3. Still doesn't work. Jackson?
n times 2?
N times 2, I think,
Oh my.
is going to be our best way to go about this. Okay?
Alec, I'm smarter than you in every way.
So if I plug in 1, I would get 2. If I plug in 2, I would get 4. If I plug in 3, I'll get 6. So, for this, we're saying that my n value, the first number I'm plugging in, is 1. And the top would be 7, right? Because 2 times 7 would get me my final term. Right? So this is how I would write this
Why are you talking so
series using summation notation. Right? How about B here? Here we've got alternating signs. It's the same thing as A, except the signs alternate. Right? I'm going 2, 4, 6, 8, 10, 12, 14, but every other term I'm subtracting instead of adding. So how do we deal with a negative sign like that? So how can I deal with this every other term is negative thing? Yeah, we're going to have to do a negative 1 to some power here. Okay, so the ones that we've looked at, we've done negative 1 to the n power. Right? So if we do negative 1 to the n, and then it's going to be the same rule as this one, right? 2n. 1, 2, 4, 6, 8, 10, 12. So let's test this out. Okay, if I plug in 1, well, that would be a negative 1 times 2. I should get negative 2 for the first one. How can I fix that? So the way that this rule is written right now, we've got all the signs in the wrong spot. We'd have negative 2, positive 4, negative 6.
Make the n parentheses.
No, almost.
Would you add a 1 to the n?
Yeah, the easiest way to fix that is just add a 1 to the exponent. So now, if I plug in 1, I'm going to have negative 1 to the second power, which would be positive 1 times 2. So we would get a positive 2 the first term. If I plug in 2, I will get negative 1 to the third power, which would be negative 1 times 4. Negative 4. Right? So when we have alternating signs, we're going to have negative 1 to some power.
Do it.
If it doesn't work for negative 1 to the n, okay, if the signs are all flipped, just add 1 to the exponent. Okay? So then, what's that? So our bounds would be the same as the first one, right? Plugging in 1 and plugging in 7 to get the last term.
This sucks. I like the other stuff on the back. The front.
Okay, let's try at least one more here.
Fair. I can do this with
Okay, 3, 5, 7, all the way up to 21.
You should make,
plus 2.
make a video for homework. So you
N
can
plus 2.
Yeah.
So let's test it. So if I plug in 1, 1 plus 2 is 3. If I plug in 2, 2 plus 2 is 4.
Oh my god. You're wrong. N times 2 minus 1. That's what it is.
2n minus 1?
Yeah.
So if we plug in 1, that would be 2 minus 1 is 1.
Wouldn't it be 2 and
Oh
plus
my
1?
god. I'm done.
I think this one's going to be 2n plus 1.
That's what I meant.
Okay. So my lower bound, if I plug in 1, I would get 3. Then what would my upper bound be? How would I get 27? Or, sorry, how would I get 21?
And just 10?
Yeah, that seems right.
2 times 10 plus 1 would be
I don't see
21.
anyone else trying to answer stuff.
Okay.